Dinosaurs have intrigued people for decades with their size, their spectacular appearance, and fierce reputations. You've seen the movies, watched the specials, maybe visited the museums. But do you really know what is a dinosaur? Coming up on this episode of the Dinosaur Hobbyist. Welcome to the first episode of the Dinosaur Hobbyist. I'm Brad Potts, and I've been exploring and reading about dinosaurs since grade school. Back when they thought dinosaurs just died out, well, because they sucked and mammals were better. I'm not a paleontologist, just an interested hobbyist, continuing my hobby and trying to share it with you. In our first episode, I'm going to address a basic question. What's a dinosaur? Is this a dinosaur? Of course it is. Is this a dinosaur? No, not even a close relative. How about this? Is this a dinosaur? We'll explore that question in a bit. How about this guy? Again, no. Indeed, this animal is more closely related to us than it is to dinosaurs. There are a few ways to address the question of what a dinosaur is. Some older ideas are now obsolete, and we've learned more about them and their history. At its most basic, dinosaurs are animals that lived in the Mesozoic era, descended from reptiles, with bird-like hips. On its surface, this remains a pretty good definition. First of all, what is the Mesozoic era? The Mesozoic, or the age of dinosaurs, spans a period of time from about 252 million years ago to about 65 million years ago. It contains three geological periods: the Triassic, the Jurassic, and the Cretaceous. This span of 185 million years was largely dominated, as the name suggests, by dinosaurs. So let's look at the second criteria, descendants of reptiles. This covers a lot of ground, and we need to be a little more specific. You and I are also descendants of reptiles after all, as are the majority of extant tetrapods. If we go back in time, way before the dinosaurs, reptiles first evolved with dry skin and the ability to lay eggs on land. These were the amniotic anapsids. Amniotic really just means they had evolved to lay eggs that no longer need to be laid in water. Most tetrapods today are descended from these early amniotes. You, me, birds, alligators. It is an important step in the evolution of land animals, dating back to at least 312 million years ago. These are not the reptiles we're looking for. Only shortly after the evolution of anapsid amniotes, the reptile line split, possibly into three groups: the stem anapsids, the synapsids, and the diapsids. The diapsids are the ancestors of most modern reptiles, and also dinosaurs and birds. Mammals are descendants of the synapsids, like our friend the Dimetrodon. And it's not clear whether there are any surviving anapsids. Turtles were thought to be, but recent fossil discoveries have cast significant doubt on that, placing them much closer to the dinosaur line. So dinosaurs are descendants of diapsids, which include all modern reptiles: lizards, snakes, crocodiles, probably turtles. Around 250 million years ago, there was a cataclysmic event in Earth's history the end Permian extinction event. Basically, an enormous eruption in what is now Siberia poisoned the atmosphere and caused runaway global warming, killing, well, everything. Only a scant few animals got through this great biological bottleneck. One of those groups were the archosaurs. Archosaurs were diapsid reptiles who had some remarkable bird-like adaptations. They had moved their limbs under the body for greater mobility and developed more efficient breathing apparatus, which was helpful in the low oxygen environment which dominated Earth immediately following the extinction event. Coincidentally, today it gives birds the respiratory abilities for flight and to survive at high altitudes. Modern archosaurs include crocodiles, birds, and possibly turtles, and of course dinosaurs. Indeed, archosaurs are the stem group from which many of our most well-known prehistoric creatures evolved, including this guy and this guy. So why aren't they dinosaurs? Well, that comes down to certain key anatomical traits, which the earliest dinosaurs evolved after these groups split off from the Lyme dinosaur ancestors, referred to as the bird-like hip, which, as I'm not an anatomist, I'm not prepared to go into in great detail, gave dinosaurs a unique anatomy from other archosaurs. So what about birds, you ask? For this, we'll change gears and definitions and talk about cladistics. A cladistic diagram shows the relationship of different animals to one another. It creates a branching off from the most recent common ancestor. So, re-examining our previous discussion, our common ancestor is that first anapsid amniote. Now, we don't know for sure what that animal was, but for our discussion, we'll call it this guy, Archaeopthyrus. A clade is the most recent common ancestor and all of its descendants. So any animal descended from Archaeopthyrus is an anapsid amniote. That includes reptiles, dinosaurs, and us. Our cladistic diagram splits from that ancestor quickly though. Off to the right are the synapsids, including all of the mammals and ourselves. But we're interested today in the left branch, the diapsids. Here's one, Petrolochosaurus. That branches again. This time, right goes off to our friends the snakes, lizards. Oh, and this guy, the mosasaur. Not a dinosaur at all. In fact, he's not even an archosaur. He's a lizard. And this is probably his closest modern relative. Continuing to the left, we have the archosaurs. We have a more recent common ancestor in the early archosaur Prehistoric. We see a number of branches of the archosaur line: ichthyosaurs, pterosaurs, crocodilians, and finally come to the very first animals that might be dinosaurs. Meet Teleocrator, a close dinosaur relative, who may closely resemble the ancestors of all dinosaurs. But we were talking about birds being dinosaurs, so we have a few more steps to go. This is Nyasasaurus, possibly the earliest known true dinosaur. 240 to 245 million years old. Exactly what is a dinosaur and what is just a close relative? Yeah, it's a little hard to tell. But we're pretty sure this is a dinosaur. And a good look at what the earliest common ancestor of all dinosaurs might look like. Our diagram continues to branch. Our first major split is the sauropods. And this is a change from the old theories based on recent discoveries. Previously, sauropods and theropods were grouped together as Saurischia due to their common lizard-like hip. But this has been challenged in recent years due to new evidence. Next to branch off, we have Ornithischia, probably the most diverse of dinosaur lineages. And then finally, as we continue up the left side of our cladistics diagram, we come to the theropods. Within the theropods, the cladistics diagram continues to diverge. There was a subgroup called Allosauridae, and within this group, raptors. Yes, those raptors. A final branch, and we're there. Birds! So, if any descendant of a common ancestor is in the same clade as the ancestor, then all we have to do is look back and see that birds are Allosauridae, which are theropods, which are dinosaurs. So birds are dinosaurs. So if you thought dinosaurs were extinct, surprise! What paleontologists say now is that non-avian dinosaurs are extinct. Now that you know what a dinosaur is, we can start to explore dinosaurs in future videos. With new discoveries coming almost every week, we are living in a golden age of dinosaur research. In the news lately, feathers came first. New research published by the University of Bristol in Trends in Ecology and Evolution has found that pterosaurs had feathers. Fossils found as long ago as the 1840s revealed that pterosaurs had fur on their heads and bodies. Paleontologists came up with the term pycnofibers to describe it and to distinguish it from the hair of mammals and the feathers of birds. In the recently discovered fossils, these pycnofibers are exceptionally well preserved. Much of the head, body, and limbs of these pterosaurs were covered by hair-like filaments, just as was long held to be the case. But the team also found 3 distinct types of branched filaments. If your dermal fluff branches, that's a feather. If correct, this shows that feathers actually evolved in the early archosaurs, before the divergence of dinosaurs, or around 250 million years ago. On July 11th, Current Biology published a report by Li Zheng from China University of Geosciences, Beijing, about his discovery of a 99 million year old bird species, Electrotornis xingguangji, or amberbird, based on the type fossil of the animal being found entombed in amber. Found in Cretaceous amber from northern Myanmar, this bird, smaller than a modern sparrow, had an enormously long 3rd digit, longer than its lower leg, and longer proportionately than any other known bird species. She and his colleagues suspect it might have served a similar role to the elongated middle finger of the aye-aye, a modern-day lemur that uses its finger to fish larvae and insects out of tree trunks. Electrotornis is a member of the group Enantiornithines, a line of early birds which went extinct during the KT extinction event and has no living descendants. Scientists have announced the discovery of a new dinosaur species, Auroroceratops rugosus, from the Gobi Desert in northwestern China. Auroroceratops lived 115 million years ago and is an early representative of the ceratopsians, which include the much larger Triceratops. Auroroceratops was 4 feet long, with the trademark frill and beak of its larger relative, but no horns. While most dinosaurs are known from only a handful of specimens, over 80 Auroroceratops have been found. It is one of only a very few early ceratopsians which a full skeleton has been discovered. A member of the subgroup Neoceratopsia, which includes Triceratops, Auroroceratops lived in the early Cretaceous, at a time when ceratopsians were still bipedal, like their ancestors. The study was first published by Peter Dodson in the Journal of Vertebrate Paleontology. Our final news item for this week is the recent discovery of an interesting member of the duck-billed dinosaurs, Equilorhinus palamentus. This animal was originally excavated in the 1980s by Texas Tech professor Tom Lehman, but lay unexamined for many years until the technology existed to look into the bone. Long thought to be the skull of a known dinosaur, this more in-depth study revealed that the specimen belonged to an entirely new group, a more primitive animal that may point to the ancestry of all duck-billed dinosaurs being in the southwestern area of the United States. Equilorhinus had an unusual W-shaped lower jaw and a simple arched nasal crest, which distinguished it from the common U-shaped jaw and more ornate headgear of other duckbills. Equilorhinus lived about 80 million years ago in what is now Big Bend National Park in Texas, and was described in the Journal of Systematic Paleontology. If you enjoyed this video, make sure to hit that like button and subscribe to support the channel and receive notifications of future videos. If you have a question about today's video or a topic you'd like discussed, let me know in the comments below.
Soundwave Senpai says, I'm excited to see more videos from this channel. Dinos having, not having feathers has been a hot topic for a good bit now. I think having that as a topic would be nifty. Cheers from Michigan.
Thanks, Soundwave, and hello, Michigan. We're excited too, mixing my passion with Tinny's YouTuber hobby to create this channel. We touched on dinosaur feathers just a bit in this video, but I'd love to dig deeper into the topic for you in the future episode. That's it for this episode. Thanks to my crew and to bensound.com for providing the music. I'm Brad Potts, and I'll see you next time on the Dinosaur Hobbyist.